3 rules of logarithms and also how to convert between logarithms and exponents, because you're going to have to use all 3 today. So here they are. No, they will not be on the test. No, I mean, the formulas won't be on the test. The need to use them will definitely be on the test. Glad I could clarify that for you. So, the product rule says if you have 2 logarithms added together that have the same base, you can combine them into one logarithm where the answers on the inside are, or the numbers on the inside are multiplied together. So positive log turns into a single logarithm where these are multiplied. That's called the product rule. Okay, likewise, if you need to split it, you can. You could go from here to there. The quotient rule is similar. If you have a positive logarithm and a negative logarithm of the same base, then this x is on top and the y is on bottom. That's the quotient rule. So basically, this is the same idea. Anything positive lands in the numerator, anything negative lands in the denominator, as long as the bases are the same. Okay? The power rule is very simple. If you have a number multiplied by a logarithm, you can take that number and lift it up and make it an exponent of the number you're taking the logarithm of. And you can convert those back and forth as needed. Okay? And then this is the conversion rule. The conversion rule says a raised to the b equals c is exactly the same thing as log base a of c equals b. Okay? So if you go backwards, a to the b is c. And that's, oh, well, that's 1 out of 4 ain't bad. If you were in the majors and you batted 250, and had, maybe if you were fast, you'd land in the Hall of Fame. Yeah. Yes. Well, you're probably not fast, so. We'll go back. I'll put it back up to you for you in a minute. Okay. Look at number 1. What would you do to solve number 1? Does the product rule apply? No, because we don't have the log of some product. We need to convert to exponent. So in exponential form, it's 3 to the third equals this. So 3 to the third is 27 equals 2x minus 1. Yeah, it's super easy. That's the one you said you knew. So we're going to add 1. What does it say? 5. Well, they don't know what they're talking about. I didn't write the answers. I stole them. I don't remember. I think an old textbook. Yeah, it says 5. That's not right. Okay, sorry. Okay. What? Keep up! I didn't write the answers. Okay, look at number 2. What would you do to answer number 2? Well, I could, don't do this. I could subtract 1 log to the other side. So I have a log base 7, positive, subtracted by another log base 7, which equals 0. And then I could use the quotient rule, and then I could convert. But if you look carefully at this, no, it's not it's not divide, because is it log base 7 times 3x minus 11? No, it's the log base 7. That's what you're doing to the 3x minus 11. But if you look at it, if I take the log base 7 of, let's say, a, and I take the log base 7 of, let's say, b, what do I know about a and b? They're the same because, I mean, well, and they're both base 7. If we do log base 7 to A and we do log base 7 of B, then really all we need is A and A equals B. Now, Tom Hansen affectionately calls this dropping a log. I don't know what he means by that, but he thinks it's really funny. So, why don't you go ask him? So, here's the thing. You can only drop the logs if you have log of one base equals a log of the same base and no other information. For instance, if it was 4 plus, that won't work. Right? The only time you can drop the logarithms is if you have one logarithm equals the same base logarithm and nothing else. Okay? If it was 4 plus, then you'd have to subtract this one over, and then you'd have to do a quotient rule, and then you'd have to convert. So this one is set up in such an easy way that we can cross those out, and we get 3x minus 11 is x minus 3, and we add 11 and subtract x. 2x equals 8, divide by 2, x is 4. That answer's not on the paper. Yeah. But who knows? Maybe they're all wrong. I stole this from the Jordan/Canyon School District, so it's on the moon. We're going to do a couple more. What? I stole the problems and the answers, but apparently when they wrote the answers, they were wrong. Yeah. Okay. Look at number 3. Now, don't write this down. If I were to subtract this log over, could I drop the logs? They have the same base. No, because that 2 is there. In order, well, if I put the 2 back there, it's still there. So, the only time you can drop logs, log base, should we say 2? Log base 2 of 4. This is the only time you can drop them. Log equals log, nothing else. Okay? That's when you can drop them. If there was like a 6 plus over here, you're not allowed to drop them. So it doesn't happen very often, but sometimes it does. So I have 2 log base 6s. Can I combine them into a single logarithm? Yes, using the product rule. And if you've forgotten it already, here it is. If we have log base 6 of something plus log base 6 of something, it's log base 6 of the product of those 2 somethings. So it would be log base 6 of 3x is 2. Now what do I do? Convert, you could guess and check. If it's a decimal, good luck. So conversion rule says 6 squared, which is 36, equals 3x, divide that by 3, and x is 12. Now, it's a good idea to check to see if you're right, especially because you can't trust the answers, apparently, on this. So, if I put a 12 in there, is 6 squared equal to 3 times 12? Yes. So that one worked. Did they get it right? Thank you, Jordan School District. Ruining our lives. Okay. What would you do with number 7? Or how about number 4? Sorry, number 4. Yeah, I've got a problem. I can't do the quotient rule at the moment. I got to move the 2 using the power rule. So this 2 comes up here. Now what? Quotient rule, which says logs of 2 of the same bases, log base 3 of x plus 4 squared. Should I multiply that out? maybe, we don't know, but if we can avoid it, let's avoid it. So let's just leave it like that until we know for sure if we need to. Because sometimes you won't need to. Sometimes you will. Over 9 equals 2. Now, this is all treated as a single number. Now what do I do? Convert. So 3 squared is 9 equals x plus 4 squared over 9. Should I multiply those together? Can I actually get to the x by pulling off the layers without multiplying them together? Yeah, in this case I can. So what do I need to move first? The 9. So times by 9. This becomes 81. Square root. If you forget the rule, I'm going to throw my marker at you. Come on. Don't let me down. No. So x plus 4 equals... No! Plus or minus 9. Ooh, Alexa saved you. I was going to throw my marker. Plus or minus 9. I don't know. I got 4 markers, so... So we're going to subtract 4, and I asked one of my earlier classes, what's plus or minus 9 minus 4? And they said, plus or minus 5. No, that doesn't work. So it's 9 minus 4 is 5, and negative 9 minus 4 is negative 13. Okay, let's double check. So if I plug in 5, 5 plus 4 would be 9, and 3 to what power is 9? 2, and 2 times 2 is 4, and what is negative log base 3 of 9? Wait a minute. This is a 2? 3 to what power is 9? 2. So, could we have used that at the beginning? Yeah, nobody noticed that, huh? So 4 minus 2 is 2, it worked. If I put a negative 13 in here, 3 to what power is negative 9, and it would be... Anyway, it works out, so... Does it? What does the answer say? Oh. So, if I tried that, so I have 2 times log base negative 13 plus 4 base 3. So that's 2 log base 3 of negative 9. And I square it. Log base 3 of negative 9 squared, which is actually 81. So it does work because of this 2. Can you take... Log base 3 of what is negative 9? There is no number that works. You cannot take the logarithm of negative numbers. So this one just happened to work because of that 2. But I don't think you're ever going to run into one that doesn't, so don't worry about it. But just plug them in to see if they work. Okay, let me show you how you would have done this the other way to make it a little bit easier. If this is a 2... then I could have added it to the other side, right? Plus 2, and I get log base 3 of x plus 4 squared equals 4, and now I can go straight to the conversion, and I don't need to use the quotient rule. So anytime you have a logarithm that doesn't have an x in it, by all means simplify that first, and then you can avoid product and quotient rules. It'll still work out in the end. It's like... we had that x plus 4 squared. If I would have multiplied that out, then I would have had a quadratic, and I would have moved some terms around, and then I would have factored it and got 5 and negative 13. But I avoided that because it made it easier. So if you look at number 5, can we simplify anything off to at the beginning? What is this really? 4 to what power is 16? 2. So I'm going to subtract this 2 to the other side, and I get equals 3. And that avoids the use of the product rule. Now you could use the product rule and you'll still get the right answer. So I'm going to move this 3 up here. Log base 4 of x minus 2 to the third equals 3. Now what? Convert. 4 to the third equals x minus 2 to the third. And before you get crazy, take a look at that. Why is it 6? This is the exponential equivalent of dropping a log, right? If I have a base to an exponent and a different base to the same exponent, then this must be the same as that. I could third root both sides and it would cancel the 3's. But if you look at this, well, 4 has to equal x minus 2, so x must be 6. Okay? So don't make these hard. Sometimes you just need to step back and look at them and say, what number would make that work? Okay, the algebra will work no matter what, but you can save yourself a lot of time if you just think about it a little. I know that's asking a lot. Okay, number 6. What would you do here? Combine them using the product rule. So I'm going to multiply this and this together. So what is the base? 10. And what is x times x minus 21? X squared minus 21x equals 2. Now what? Now we got to convert to exponent. So what's the base? 10. 10 squared would be 100 equals x squared minus 21x. Now what? I need to set it equal to 0 so I can factor it. It's a quadratic. So I subtract the 100 to the other side. X squared minus 21x minus 100 equals 0. So I'm looking for two numbers that multiply to be negative 100 and add to be negative 21. Negative 25, well, they're not two negatives. One's positive, one's negative. So x minus 25 and x plus 4. So what are my two answers? 25 and negative 4. Okay. You know what? This is one of those cases where it doesn't work. Well, look at the negative 4. Can I put negative 4 in here? 10 to what power is negative 4? There isn't one, so actually this is not a solution. Okay, so 25 is the answer. And 25 works in both of them. Log base 10 of 25 plus log base 10 of 25 minus, anyway, it works. So, skip down to number 10. This is similar to what you did yesterday. What's our solution method here? ln both sides. That allows you to drop the x. So x ln of 3 equals the ln of 25. I do that because I turn an exponential problem into a multiplication problem. Then I divide by the ln of 3. And whatever decimal you get there is going to be the answer. So hopefully that was review. If you look at number 13, can I take the natural log of, well, would it do me any good to take the natural log of both sides at this point? No. The reason is, I have 30 to the first and e to the 0.6x. If I take the ln now, the power rule does not apply because I have two different numbers with two different exponents. So in order for the power rule to work, the exponent number has to be by itself. So you divide by 30. And then you have e to the 0.6x equals 8. The nice thing about natural log, when you have base e in your exponent, it works out really well. Drop this down. What is the ln of e? E to what power is e? 1, and 0.6x times 1 is just 0.6x. So every time you're solving for an exponent and your base is e, use the natural log, because ln of e turns into 1. So in this case, since it's a multiplication problem, we can just kind of cross it out. Oh, I still have ln 8 on that side. And I divide by 0.6. So x is ln 8 over 0.6. If you get into higher math, a lot of times they call the ln the ln. Don't know why. If it grows too high, you have to mow it. Does it? There's no 13? Their answers are all screwed up, huh? Yeah, I don't know why they do that. I just took what they gave me. Maybe. Maybe the answers aren't going to do you any good. Okay. Nope, you're just doing the front page. Yeah, and I'm going to be gone tomorrow along with a lot of you. Leslie will teach you the stuff on the back. Okay? But don't throw the answer page away, because there's still some problems on the answer page. So. You what? Well, don't believe the answers if you don't want to. But there's still some problems you have to do. So staple those 2 pages together. All right. Good luck.